Okay, so for number one, we're supposed to find sine and cotangent given secant and the sine of cotangent. So let me go ahead and write that down. So for number one, it says find sine of theta and cotangent of theta if secant of theta equals a negative 5/4 and cotangent of theta is greater than 0, which means it's positive. Okay? So if you're dealing with secant is the reciprocal of cosine. So if secant is negative 5/4, that means cosine is negative 4/5. Cosine is only negative, if you think about your bow tie. Cosine is only negative when we're going to the left because it's adjacent over hypotenuse, whereas over on this side, adjacent is going to the right. That's positive. So those two are out. And then cotangent is greater than 0, which means cotangent is positive. Well, cotangent is positive when you got adjacent over opposite, and the only way you're going to get positive is if they're both positive or they're both negative. In the second quadrant, this is positive, so opposite is positive and adjacent is negative, but in the third quadrant, adjacent is negative and opposite is negative. So we must be in the third quadrant. So I'm going to draw a triangle in the third quadrant with theta as my central angle. And secant is, again, hypotenuse over opposite. So hypotenuse is going to be 5, adjacent. Adjacent is going to be 4. One of them gets the negative, and it's definitely going to be the adjacent, not the hypotenuse, which is never negative. Now, we do know from Pythagorean triples that this is a 3, 4, 5 triangle, so we're going to make that a 3. But then remember location, it's going down, so that would be negative. One way to check yourself is always check. So is secant still negative 5/4? And if we'd done that, we would have said yes. And then is cotangent positive? Well, if I hadn't put that negative there, cotangent would have been negative 4 divided by 3, which is negative, so that doesn't fit the criteria. Okay, yeah, I need that negative. Okay, so then I can just use this to fill out these two. Sine is opposite over hypotenuse, so that's going to be a negative 3/5. And cotangent is adjacent over opposite, so that's going to be a positive 4/3. Okay. Number two. Number two says to find cotangent and tangent. So cotangent and tangent. If cosine is 4/7 and cosecant is negative. Okay, so I've got cosine is a positive 4/7. Cosine is adjacent over hypotenuse again. So the only way that adjacent over hypotenuse is going to be positive is if adjacent is positive. So when I think about going left versus right, going to the right you've got positives on adjacent, and going to the left you've got negatives. So it can't be going to the left. And then cosecant is negative. Cosecant is the reciprocal of sine. So if sine is negative, that means you're going down into the fourth quadrant, not up into the first. So we are definitely in the fourth quadrant. So I've got a triangle in the fourth quadrant with theta as my central angle. Cosine is a positive 4/7. And the Pythagorean theorem says that a squared plus b squared equals c squared. So 16 plus b squared equals 49, which means b squared equals 33, which means b equals the square root of 33, plus or minus, and in this case it is going to be the minus because we are going down the y-axis, okay? So the question is, what is cotangent and what is tangent? Tangent is opposite over adjacent, which is just negative square root of 33/4. And cotangent is the reciprocal of that, adjacent over opposite, 4 over the negative square root of 33. But you're going to have to rationalize that and bring the negative up, so negative 4 root 33 over 33. And there we go. Okay, let's go to number 3. Number 3 asks us to find sine of 165 degrees. So, sine of 165 degrees. Using half angle identities. So I'm going to remind us of what that half angle identity for sine is. The sine of an angle cut in half equals either positive or negative the square root of 1 minus cosine of x divided by 2. So what I want to do is I want to figure out how to use this half angle identity. Sine of x divided by 2 equals either plus or minus the square root of 1 minus the cosine of x divided by 2. Okay, so here's what I know. 165 is not on my unit circle, but 165 times 2 is. I wouldn't be asking you to do to use half angle identities if it wasn't. So this is 330 degrees, which means that sine of 165 is equivalent to me saying sine of 330 cut in half. So the advantage of this is that I can plug 330 in for x, and I know what cosine of 330 is, whereas sine of 165 I don't know. Okay, well, so I've got to deal with first off this plus or minus, right? So is it plus or is it minus? Well, let's go back to the original expression, sine of 165 degrees. So 165 degrees is in the second quadrant in here, and sine in this quadrant is positive because we're going up. So it is definitely the positive. And then we've got 1 minus cosine of this angle, so whatever this angle is, that's the same. Cosine of 330 degrees, all divided by 2. So cosine of 330 degrees, so if I look at 330 degrees, cosine is the square root of 3 over 2. It's probably kind of blurry. Okay, so square root of 300 over 2, so we're going to replace that. The square root of 1 minus the square root of 3 over 2 all over 2. But then I don't want fractions within fractions. So we're going to rewrite this 1 as 1 over 1 and then multiply by 2 on top and bottom. So then this becomes the square root of 2 minus the square root of 3 all divided by 2. So this is just the numerator. And then divided by this 2 down here, which is the same thing as 2 over 1, right? And this is all within the square root. Okay. Well, if you divide a fraction by a fraction, you can flip and multiply. So we're going to multiply by 1/2. And then this becomes the square root of 2 minus the square root of 3 all divided by 4, because it's 2 times 2. But then I can take the square root of the 4, and so final answer is going to be the square root of 2 minus the square root of 3 all divided by 2 outside of the square root. Okay, and there's my answer. So I box that. Alright, let's look at number 4. Number 4 says find the sine of 9 pi over 8. Okay, so first let's talk about 9 pi over 8. It's not on my unit circle. I don't have any 8s memorized. It's not one of the main ones on the unit circle, I mean. But 9 pi over 8, so when you think about 9/8, 9/8 is a little more than 1, so it's going to be somewhere in here. And if you think about sine in this quadrant, when you go to the left, cosine is negative. But when you go down, sine is also negative. So in that quadrant, sine is negative, so when we use this identity, sine of x divided by 2 equals plus or minus, we're definitely dealing with a negative on this one, because we are in, the original angle is in the third quadrant. So it is negative. But first I gotta figure out what my x is, right? So in order to figure that out, up here I multiplied 165 times 2, I'm gonna do the same thing. I'm gonna multiply 9 pi over 8 times 2. Well, that becomes 9 pi over 4, which, again, is not necessarily one of my memorized ones, but I know it's a fourth. And if I think about fourths, you know, you got 1/4, 2/4, 3/4, 4/4. This is 8/4, so 9/4 is right here. 9/4 might as well be 1/4 pi. Or, if you want to think about it, you can take 9 pi over 4 and subtract a rotation, 2 pi. And then just say over 1, multiply by 4, so that's 8 pi over 4. So 9 pi over 4 might as well be pi over 4. Okay? So, I'm going to go ahead and use 9 pi over 4, but then I'm going to remember that whenever I figure it out, I'm going to use pi over 4. So sine of 9 pi over 8 is equivalent to saying sine of a half of 9 pi over 4. And literally, if you just multiply these together, you get 9 pi over 8. So that is an equivalent expression. But I know this identity says, again, 9 pi over 8 is just over pi in the third quadrant, which means sine is going to be negative. the square root of 1 minus cosine of 9 pi over 4, all divided by 2. Well, cosine of 9 pi over 4, again, might as well be dealing with pi over 4, and cosine is square root of 2 over 2. So this is going to be the negative square root of 1 minus the square root of 2 over 2, all over 2, which is over 1, and we're going to do that whole flip and multiply in just a second. I'm going to multiply this on top and bottom by 2, so common denominator, negative square root of 2 minus the square root of 2, all over 2, divided by 2 over 1, flip and multiply by 1/2, and this becomes the negative square root of 2 minus the square root of 2, all divided by 2 times 2, which is 4. But then, final answer, we're going to take the square root of 4, and that becomes just 2. So my final answer is going to be negative square root of 2 minus the square root of 2, all divided by 2. And there's my final answer for that. Okay, let's go to number 5. Tangent of 67.5. So tangent of 67.5 degrees. Okay, so first let's place the quadrant. 67.5 degrees is in the first quadrant, so tangent of that, everything in that quadrant is positive. So if I were to use this first identity, I would have to recognize that it's positive, but I'm going to use the second one probably, so I don't need to worry about it. I'm going to go ahead and write that down. Tangent of half angle equals 1 minus cosine of the angle divided by sine of the angle. Okay, so I'm going to multiply 67.5 times 2, so 2 times 67.5, 120, 134, 135. Okay, so that is 135 degrees, which means tangent of 67.5 might as well be tangent of 135 degrees cut in half, which means I might as well be finding 1 minus cosine of 135 degrees divided by sine of 135 degrees, if I follow the identity. Okay, so let's go to 135 degrees. At 135 degrees, cosine is negative square root of 2 over 2, and sine is positive square root of 2 over 2. So cosine is negative square root of 2 over 2, so this is going to be 1 plus square root of 2 over 2 divided by sine, which is the positive square root of 2 over 2. We're going to do some common denominator work and simplify, and there's going to be our answer. So 2 over 2, my numerator becomes 2 plus the square root of 2 all over 2. Divided by the square root of 2 over 2 means multiply by 2 over the square root of 2. So those are going to simplify out, and I'm left with 2 plus the square root of 2 all over the square root of 2. Okay, so 2 plus the square root of 2 all divided by the square root of 2. Good. And then I'm going to go ahead and rationalize. I'm going to multiply top and bottom by square root of 2 and see what happens, okay? So if I distribute it to the numerator, I get 2 square roots of 2 plus 2, all divided by square root of 2 times square root of 2, which is 2. But each of these is divisible by 2, so final answer, I'm going to say, is square root of 2 plus 1. 2 divided by 2 is 1, 2 divided by 2 is 1, so 1 square root of 2 plus 1. And there we go. 1 plus the square root of 2, or square root of 2 plus 1. Let's go to number 6. Number 6 says tangent of 13 pi over 12. So tangent of 13 pi over 12. Let's place that. 13 twelfths is just over 12 twelfths, which is 1. So if this is pi, then 13 twelfths is in here. Tangent in this quadrant, if you go left and down, that's going to be a negative divided by a negative. That is positive. So, I mean, if I had to worry about it. But I don't, because I'm going to use that one again. So tangent of half angle equals, again, 1 minus cosine divided by sine of whatever that angle is. So let's multiply this in times 2. 13 pi over 12 times 2 equals 13 pi over 6. So tangent of 13 pi over 12 is equivalent to tangent of half of 13 pi over 6. So 13/6 is not on my unit circle, but it's very similar to the one we did a second ago with 9 pi over 8. 13/6 is just 1/6 more than 12/6, which is 2 pi. You can also do the whole subtract. So 13 pi over 6 minus 2 pi. 2 pi is the same thing as 12/6, and so that is going to be 1/6 pi. Okay, so when I deal with this, I might as well be dealing with pi over 6 as opposed to 13 pi over 6. So I'm going to use this identity. 1 minus cosine of 13 pi over 6, because whatever angle I cut in half, that's what I plug into here, divided by sine of 13 pi over 6. But again, 13 pi over 6 might as well be pi over 6. So 1 minus cosine of pi over 6 is square root of 3 over 2. And divided by sine of 13 pi over 6, which might as well be pi over 6. And sine of pi over 6 is 1/2. So common denominator, 2 over 2, is that 1? So I've got 2 minus the square root of 3 all over 2 divided by 1 over 2, flip and multiply by 2 over 1. The 2 simplify out, final answer is going to be 2 minus the square root of 3. And there we go. So that's number 6. Let's go to number 7. Number 7 says to simplify, and I'm going to write it out. So number 7. Simplify tangent, and it doesn't have parentheses, but I'm going to go ahead and add them. For some reason the program won't let me add them. Tangent of negative 6x minus tangent of positive 6x, all divided by 1 plus tangent of negative 6x times tangent of positive 6x. So when I look at my identities page, I recognize this as this situation right here. Okay, tangent of an angle plus or minus tangent of another angle, and then 1 minus plus, so whatever this is, that's the opposite tangent of the same and tangent of the same, which means this is just an alpha and a beta situation, tangent of an alpha plus or minus a beta. So I can go ahead and say that this is equivalent to tangent. I already know my alpha and my beta. My alpha is negative 6x, my beta is positive 6x. The only question is it plus or minus? So in the formula, if it's plus here, then it's plus on top. And if it's minus here, then it's minus on top, opposite on the bottom. So because this is minus on the top, if this is minus, then that's minus. So this is going to be minus. So what we're really just trying to ask you to find is what's tangent of negative 12x. And you're not going to do anything with that. That is your answer. Okay. Number 8 is a very similar problem. It says sine of negative 2u, sine of negative 2u times cosine of 4u minus cosine of negative 2u times sine of 4u. So sine cosine minus cosine sine. Okay, so this one has sine cosine sine cosine, this one has cosine cosine sine sine. The only one that switches is going to be this sine one up here, so it's okay if the order is a little bit different. Sine of beta times cosine of alpha, same thing as cosine of alpha times sine of beta. So it looks like they just kept the 2u and the 4u in the right order. Okay, so I'm thinking for sure it's a sine of alpha plus and minus beta. So that is equivalent to saying sine, the alpha is negative 2u, the beta is 4u. And for sine, if you've got a minus in the middle, it's the same as what's inside here, plus minus plus minus. So if this is a minus, this is a minus, this is a plus, that's a plus. So because this is a minus, this is a minus. And so the question is, we're really just asking what sine of negative 6u, which that is the answer. I'm not expecting you to do anything with that. Number 9 says find the exact value. So very similar to what we just did, but this time we're actually going to figure out what it equals, because it's going to simplify something. Okay, number 9. We've got tangent of 2 pi over 9 plus tangent of 4 pi over 9 divided by 1 minus tangent of 2 pi over 9 times tangent of 4 pi over 9. Okay, so using my identity, this is, I've got a tangent plus a minus a tangent over 1 plus or minus plus a tangent times a tangent. Those angles, alpha and beta, look like they're 2 pi over 9 and 4 pi over 9. So I know it's tangent of alpha, 2 pi over 9, and then something beta, 4 pi over 9. The formula, I've got a plus in the numerator, so if you have a plus here, that means you have a plus there, which means plus. Which means I'm really just asking you to find tangent of, they have a common denominator, so 2 plus 4 is 6 pi over 9. But 6 pi over 9 is the same thing as 2/3. So the tangent of 2/3 pi is what we're actually trying to find. So we're going to go to 2/3 pi is right here. Tangent is sine over cosine. So let's focus on this. Okay. So tangent is sine over cosine. So that's going to be square root of 3 over negative 1, which is just going to be negative square root of 3. And there we go. Alright. Number 10. Number 10 says to find sine of 94, the implication being degrees, cosine of 26 degrees, plus cosine of 94 degrees times sine of 26 degrees. And if it bothers you, you can rewrite that as sine of 26 cosine of 94 to fit better the identity. So sine of 94 cosine of 26, sine of 94 cosine of 26, and then plus sine of 26 cosine of 94. So my alpha and my beta are 96 and 24, and it's sine. So this is going to be sine of 94 degrees, 26 degrees. There's a plus in between them, and on the sine identity, if it's a plus, then it's a plus. So plus. So 90 plus 20 is 110, plus another 10, that's 120 degrees. So we're really just asking what sine of 120 degrees. And we look at our unit circle. Back to 2 pi over 3, oh well. Sine is the y value, which is going to be positive square root of 3 over 2. So that is the answer, square root of 3 over 2. So, that's that. And there we go. Okay. And that is the end of first page, so I'll end this video for the first one.